Our next topic is something called immediately invoked function expressions. So let's take a look at what they are. So sometimes in JavaScript we need a function that is only executed once and then never again. So basically a function that disappears right after it's called once. And this might not appear to make much sense right now, but we actually need this technique later, for example with something called async await. So how could we do that? Well, we could simply create a function and then only execute it once. So run once function. This will never run again, and then we can call it here. However, we can actually run this function again at some other point in the code if we wanted to, right? There's nothing stopping us from later doing run once again, right? And so this is not what we want to do. We want to actually execute a function immediately and not even having to save it somewhere. And so this is how we do that. So we simply write the function expression itself, so without assigning it to any variable. Now, if we try to run this, we will get an error for now. And so it says function statements require a function name. And that's because, of course, JavaScript here expects a function statement, because we simply started this line of code here with the function keyword. However, we can still trick JavaScript into thinking that this is just an expression. And we do that by simply wrapping all of this into parentheses. And so now we basically transformed the statement that we had before into an expression. And so now if we save this, we get no error. But also this function didn't execute yet, right? We never called it. So we know that this here is the function, and so we can then immediately call it. And so with this, we will get now this text here logged to the console, this string. And indeed, here it is. All right. So again, this here is really just the function value. So it's just a function expression. And then immediately we call it here. And so this is why this pattern here is called the immediately invoked function expression, or IFI for short. So immediately invoked function expression. And the same would, of course, also work for an arrow function. So let's just copy this. This will also never run again. So if we try to call it like this, then it would not work. And so we actually don't get an error, but also nothing happens. So we first need to wrap this into parentheses, and then as we call it, then here it is. Okay, so two ways of writing an immediately invoked function expression. But you might be wondering, why was this pattern actually invented? Well, we already know that functions create scopes, right? And what's important here is that one scope does not have access to variables from an inner scope, right? For example, right here in this global scope, we do not have access to any variables that are defined in the scope of any of these functions here, right? So, for example, let's add a variable here. Let's say is private equal to 23, and then as we tried to access it out here, you already know that it's not going to work, right? And that's because the scope chain only works the other way around. So the inner scope would have access to anything defined outside here in the global scope, but the other way around, the global scope does not have access to anything that is inside of a scope. So in this case, of the scope created by this function here. Therefore, we say that all data defined inside a scope is private. We also say that this data is encapsulated. So, for example, this is private here is encapsulated inside of this function scope that's created here. And data encapsulation and data privacy are extremely important concepts in programming. So many times we actually need to protect our variables from being accidentally overwritten by some other parts of the program or even with external scripts or libraries. And I'm going to talk in detail about these concepts in the object-oriented programming section. But for now, keep in mind that it's important to hide variables and that scopes are a good tool for doing this. And this is also the reason why the immediately invoked function expressions were invented. So basically this pattern here. So this is not really a feature of the JavaScript language. It's more of a pattern that some developers came up with and that then started to being used by many other developers. Now, do you remember what also creates a scope in ES6? And that's right, variables declared with let or const create their own scope inside a block. And we learned that in the behind the scenes section. Remember? So when we create a block like this and declare is private in there, then the outside can still not access is private. So let's comment out this one and paste it here. And once again, we cannot access this variable. While on the other hand, this one here would of course be accessible. And so again, that's what we learned in one of the previous sections. So that's because this one here was declared with var, and therefore it does completely ignore this block here, essentially. And this is the reason why now in modern JavaScript, immediately invoked function expressions are not that used anymore. Because if all we want is to create a new scope for data privacy, all we need to do is to just create a block like this, right? There's no need to creating a function to create a new scope. Unless, of course, we want to use var for our variables, but we already know we probably shouldn't do that, right? Now, on the other hand, if what you really need is to execute a function just once, then the IFI, so the immediately invoked function expression pattern, is still the way to go, even now with modern JavaScript. There is an almost mystical feature of JavaScript functions that many developers fail to fully understand. And what I'm talking about is something called closures. So when I ask my students what's the hardest JavaScript concept to understand, then many people say that it's closures. However, I believe that with the right explanation, it's actually not that hard, especially when you already understood everything that you learned before in this course, such as execution contexts, the call stack, and the scope chain. Because closures kind of bring all of these concepts together in a beautiful, almost magical way. So enough talk, let's see what closures are all about. So I'm going to start by creating a new function here called secure booking. And it is this function that will create the closure. Now, the first thing that I need to tell you about closures is that a closure is not a feature that we explicitly use. So we don't create closures manually like we create a new array or a new function. So a closure simply happens automatically in certain situations. We just need to recognize those situations. And so that's what we're going to do here in this example. So we will create one of those situations so that we can then take a look at a closure. So anyway, let's now continue writing this example. And I'm calling this one passenger count, and it will start at 0, but we will be able to manipulate it. And I'm calling this function here secure booking because this passenger count variable cannot be manipulated and accessed from the outside. So, and now what's special about this function is that it will return a new function. And what we do in this function is to update the passenger count variable. So the variable that is defined in the parent function. So that's important. And then let's just log the new passenger count to the console. So passenger count. All right. And now let's call the secure booking function and then store the result in a variable called booker. And so this is actually pretty similar to what we did previously in the lecture of functions returning other functions. So we have one function here that we call, and this function will return this new function. And so as we call secure booking, it will return exactly this function, and it will then be stored inside this booker. And so this here is going to be now a function as well, right? So let's analyze in detail what happens when this line of code here is executed using all the concepts that we already know about. So this is exactly the code that we just wrote. Now, before we start running the secure booking function down here, our code is running in the global execution context. And in there, we currently only have this secure booking function. And so we can also say that the global scope now contains secure booking. Then, when secure booking is actually executed, a new execution context is put on top of the execution stack. Now, remember, each execution context has a variable environment, which contains all its local variables. In this case, it only contains the passenger count set to 0. This variable environment is also the scope of this function. And so the scope chain of this execution context looks like this. So passenger count is in the local scope, but of course this scope also gets access to all variables of the parent scopes. And in this case, just the global scope. Anyway, in the next line of the secure booking function, a new function is returned, and it will be stored in the booker variable. So the global context now also contains the booker variable. And now what else happens when the secure booking function returns? Well, that's right, its execution context pops off the stack and disappears. So the secure booking function has done its job and has now finished execution. It really is gone now. And that's important to be aware of and to keep in mind. And for now, that's actually all we did. So all this is nothing new at this point, right? All we did was to analyze the call stack and the scope chain as we call the secure booking function. And this is going to be important to later on understand the closure. So as of yet, we didn't see the closure yet. All we did was use the knowledge that we already have to understand how this booker function was created, because that's going to be important for the next step. So let's now go back to our code to actually use the booker function and then finally see the closure in action. So now that we understand how the booker function was created, let's now actually call it here. So we're calling it a couple of times here. And as we can see, it doesn't need any arguments. There's no list of parameters, right? So let's call it here 3 times. And now let's reload the page here. And indeed, we get 1, 2, 3 passengers. And so what this means is that the booker function was in fact able to increment the passenger count to 1, then to 2, and then to 3. But now, if we think about this, then how is this even possible? How can the booker function update this passenger count variable that's defined in the secure booking function that actually has already finished executing? And so, as I just said, this function has already finished its execution. It is gone. So its execution context is no longer on the stack, as we just saw in the slide. But still, this inner function here, which is the booker function, is still able to access the passenger count variable that's inside of the booker function that should no longer exist. And maybe you can guess that what makes this possible is a closure. But before I explain exactly how the closure works, I want you to appreciate once more how strange this actually is. So again, this Booker function here is simply a function that exists out here in the global environment, or in the global scope, right? And the environment in which the function was created, so this here, basically, this environment is no longer active. It is in fact gone. But still, the Booker function somehow continues to have access to the variables that were present at the time that the function was created, and in particular, this passenger count variable here. And so that's exactly what the closure does. So we can say that a closure makes a function remember all the variables that existed at the function's birthplace, essentially, right? So we can imagine the secure booking as being the birthplace of this function, so of the Booker function, essentially. And so this function remembers everything at its birthplace by the time it was created. And this cannot simply be explained with the scope chain alone. So we need to also understand the closure, and so let me now really explain how it actually works. So this is how we left the call stack and the scope chain after the last slide. And the most important thing to notice here is that the execution context of secure booking is no longer on the call stack, because again, this function has finished execution long ago. So now it's time to finally run the Booker function and see exactly what's gonna happen here. And note that Booker is really this function here located in the global scope. Anyway, the first thing that's gonna happen is that a new execution context is created and put on top of the call stack. And the variable environment of this context is empty, simply because there are no variables declared in this function. Now, what about the scope chain? Well, since Booker is in the global context, it's simply a child scope of the global scope, just like this. But maybe now you're starting to see the problem. So how will the Booker function access the passenger count variable? It's nowhere to be found in the scope chain, right? So this is where we start to unveil the secret of the closure. And the secret is basically this. Any function always has access to the variable environment of the execution context in which the function was created. Now, in the case of Booker, this function was created, it was born in the execution context of secure booking, which was popped off the stack previously. Remember? So, therefore, the Booker function will get access to this variable environment which contains the passenger count variable. And this is how the function will be able to read and manipulate the passenger count variable. And so it's this connection that we call closure. So let's say all that again to make this really clear. So a function always has access to the variable environment of the execution context in which it was created, even after that execution context is gone. And this last part is really important. The closure is then basically this variable environment attached to the function, exactly as it was at the time and place that the function was created. And this probably still sounds confusing, but don't worry, I have some more familiar analogies in the next slide. For now, we are just trying to understand the mechanism behind the closure, so how it all works behind the scenes. So what matters the most here is that the Booker function has access to the passenger count variable because it's basically defined in the scope in which the Booker function was actually created. So in a sense, the scope chain is actually preserved through the closure, even when a scope has already been destroyed, because its execution context is gone. This means that even though the execution context has actually been destroyed, the variable environment somehow keeps living somewhere in the engine. Now we can say that the Booker function closed over its parent scope, or over its parent variable environment. And this includes all function arguments, even though in this example we don't have any. And now this attached or closed over variable environment stays with the function forever. It will carry it around and be able to use it forever. To make it a bit more digestible, we can also say that thanks to the closure, a function does not lose connection to variables that existed at the function's birthplace. That's a bit more intuitive, right? But anyway, let's see what happens now with execution of the booker function. So the function attempts to increase the passenger count variable. However, this variable is not in the current scope. And so JavaScript will immediately look into the closure and see if it can find the variable there. And it does this even before looking at the scope chain. For example, if there was a global passenger count variable set to 10, it would still first use the one in the closure. So the closure basically has priority over the scope chain. And so after running this function, the passenger count becomes 1, this message is logged, and then the execution context is popped off the stack. Then execution moves to the next line, we get a new execution context, and the closure is still there, still attached to the function, and the value is still 1. And so now this function executes, increasing the passenger count to 2 and logging a message again. Okay, and that's what closures are and how they work behind the scenes. And I know that this is all quite complex, so let me give you a couple different definitions of closure now, some more formal ones and some more intuitive and maybe easier to grasp. And the most formal definition of closure is the one we already saw, which is that a closure is the closed over variable environment of the execution context in which a function was created, even after that execution context is gone. Or, in other words, even after the function to which the execution context belongs has returned. Next, and a bit easier to understand, a closure gives a function access to all the variables of its parent function, so the function in which it is defined, even after that parent function has returned. So the function keeps a reference to its outer scope even after that outer scope is gone, which basically preserves the scope chain throughout time. Alright, another definition, or let's say analogy, is that a closure makes sure that a function does never lose connection to the variables that existed at the function's birthplace. It remembers the variables even after the birthplace is gone. It's like a person who doesn't lose connection to their hometown. In this analogy, the person is the function and the hometown is the function's parent scope, and the function then doesn't lose the connection to the variables stored in this parent scope. And I hope that makes sense. Finally, some people like to think of this attached variable environment as a backpack. So in this analogy, a function has a backpack which it carries around wherever it goes. And this backpack contains all the variables that were present in the environment in which the function was created. Then, whenever a variable can't be found in the function scope, JavaScript will look into the backpack and take the missing variable from there. So kind of similar to the other definitions, but maybe a little bit more visual. So these are some different ways of defining closure, but they all mean the same thing. So they all represent the same idea. Finally, we need to understand that we do not have to create closures manually. And this is also what I already touched on at the beginning of the lecture. So instead, this is something that JavaScript does completely automatically. We don't have to do anything. Also, there is no way for us to explicitly access closed over variables. That's because closures are not like a tangible thing. They're not like an object or so that we can access. So we cannot just reach into a closure and take variables from it. That's impossible, because a closure is just an internal property of a function. We can observe that a closure happens, because functions magically keep having access to variables that should no longer exist, but we cannot directly access these variables. However, what we can do is to actually take a look at this internal property, so at this backpack, so to say, in the console. So let's quickly do that before we finish this lecture. And we can do this by using console.dir, and then of the Booker function itself. So similar to console.log, but this one is a bit different. And so here we now get this function itself. So we can get the arguments, the name property that we already took a look at before, and then down here we have this scopes internal property. And this internal scopes property here is basically the variable environment of the Booker function. Now in here we can actually see the closure coming from secure booking. All right, and so this is where we see the passenger count, which currently stands at 3. And so this closure here basically is the variable environment of this secure booking. So that's the one that is being preserved by the closure. All right. And by the way, whenever you see these double brackets here, that means that it is an internal property which we cannot access from our code. All right. This was a long video about closures. Now, in the next lecture, we're going to take a look at 3 more examples of closures and also analyze how they work, because it's really important that you understand this concept of closures. It's a feature that's used all the time in JavaScript, and many times even without us realizing that closures are happening. So if you want to become confident as a programmer, you always need to know how exactly everything in your code works. And that, of course, includes closures. Let's now create 2 more situations in which closures are gonna appear, so that you can start identifying closures in your own code in the future. And both of these examples are gonna demonstrate that we don't need to return a function from another function in order to create a closure. All right, so let's start with our first example here. I'm going to start by defining an empty variable called f, and then a function expression g, so these are just some generic names, because what the functions do here don't really matter. Then in here I defined this a variable, and then I'm going to reassign the f variable that we created out here, and I'm going to assign it a function value. And this function will then simply log the a variable to the console, let's say times 2. Okay, and that's it, for now at least. So let's try to call g. So that's going to be this first function. And so the result of this function is that a will be 23, and that our f variable that we have out here will become this function. And so after g, we can then call f. So let's try that. And we get 46, which is indeed 23 times 2. All right. And so what this proves is that this f value here, so this f function, really does close over any variables of the execution context in which it was defined. And that is true even when the variable itself, so f here, was technically not even defined inside of this variable environment here, right? So this f variable was defined outside here in the global scope. It was created here. But then as we assigned it a function here in this g function, So right here, it then still closed over the variable environment of the G function. And that includes this A variable. And therefore, it is able to access this A variable here, even after the G function here at this point has, of course, already finished its execution, right? So that's just what we learned in the last lecture. So at this point of the execution, the variable environment of G is no longer there, right? But F, so this function here, closed over that variable environment, and therefore it is able to access the A variable. So basically, using the analogy of our last video, the A variable is inside the backpack of the F function. But now let's take it to the next level and create a new function here. So that's H, and it's going to be very similar. All it's going to do is to define B as some other value, let's say this, and then we will again reassign F right here. So let's call this one B now, of course. So this one here will then try to access B and multiply by 2. Okay? And so what I want to see with this is what happens when we assign the F value a second function. Okay? So here we call G, and so G will then assign to our empty variable this F function. Okay? And then if we call H afterwards, or actually let's do it after calling F for the first time. So as we then call H, then the F variable will be assigned again. So then a second function, which is this one here. And so what I want to see is what F does then. So let's see. And again, keeping in mind that F at this point is a different function than this one here, because it was reassigned by H. We just write that here. Okay, and now we get 1554, which is probably 777 times 2, and indeed it is. And so this proves that the F function that was reassigned here also closed over the variable environment of H. And so that's how it can access then the B variable here, which is set to 777. So let's actually inspect the variable environment like we did by the end of the last video. So of F. And then we will be able to see that in the closure, it does indeed have the value of B. And it now no longer has the value of A. So of the closure that it used to have before. So at this point here, the closure contained the value A. And we can, of course, also see that. So at this point in time, the closure is indeed A23, right? And so then as we reassign the function to a new value, then that old closure basically disappears. And yeah, now the closure is B. So this variable here of the birthplace where it was reassigned. And this is really fascinating in my opinion, that the closure can change like this as the variable is reassigned. So it really is true that a closure always makes sure that a function does not lose the connection to the variables that were present at its birthplace. So it's always going to remember them. And in our case here, the function was kind of born inside of G first, and then it was essentially reborn again in H. And so first, the closure contained the A variable of its first birthplace, and then as it was reborn, to follow our analogy, then it remembered this B variable of its birthplace. Okay? So this was example 1. Let's now create another example. Okay, so I hope the first one was clear here. So whenever something like this happens, where you reassign functions, even without returning them, keep in mind that also this will create a closure. But now moving on to our second example here, and that's going to be a timer. So a timer is another great example that we don't need to return a function to see a closure in action. So here I'm going back to the example of the airline. So creating a function called board passengers, and then we get the number of passengers and a wait time. Then let's create a new variable in here, which I'm calling per group, and that's because boarding usually happens in groups, and we usually have 3 groups. So I'm going to divide all the passengers, so the number of passengers that is boarding, by 3. And by the end of this function, I want to log to the console, we'll start boarding in, then wait seconds. Okay, and now let's actually use a timer. And we haven't actually used a timer yet in this course, and we will learn more about them later. But this is such a good use case that I wanted to use a timer now. And it's actually very simple. So we just use the set timeout function. And the set timeout function needs 2 parameters. The first one is a function which will be executed. Okay, and this function will be executed after a certain time. For example, we can specify 1000 milliseconds because the second argument here is milliseconds. And so that will mean that whatever code is inside of this function will be executed after 1 second. So let me actually do that out here, just so you see this as an example. So if I save this now, wait 1 second, and then here you see timer appearing. So I'm going to do that again. Okay, so you see that after this 1 second, this function was executed. Okay, and so this, as we already learned before, is essentially a callback function. And in this case, it is literally called later. So in this case, after 1 second. So let's create our callback function here. And first, I want to log to the console. We are now boarding all, and then the n passengers. And so this n here is this parameter of the function. So of this parent function, which essentially is the function or the scope in which this callback function here is being created. And so that will of course be important for our closure example. And then let's also use the per group variable now. There are 3 groups, each with passengers. Okay, that's our function, and now let's call it. Oh, and here we want to specify wait, and then times 1000, because we're going to pass in the wait in seconds. And this argument here needs to be in milliseconds, and so we just multiply by 1000. So, board passengers, let's say we have 180 passengers, and it takes let's say 3 seconds. So immediately when we call this function, this variable will be created, then set timeout will be called, and it will basically register this callback function here, and then that will be called after 3 seconds. But immediately also this console.log here will be called. All right. So this console.log here will not wait these 3 seconds for the set timeout callback to finish. Okay. So immediately this variable is created, the set timeout function is run, and console.log is run. And then after 3 seconds, this function here will be executed. And so let's see what happens to the n variable and to the per group variable that is in this function. So immediately we get this log. And then after 3 seconds, we are boarding all 180, and there are 3 groups with 60 passengers each. Okay, it worked. And again, keep in mind that this callback function here was executed completely independently from the board passengers function. All right, but still, the callback function was able to use all the variables that were in the variable environment in which it was created. So that's n and per group. And one more time, this is a clear sign of a closure being created, right? So the only way in which this callback function here can have access to the variables that are defined in the board passengers function that has long finished execution is if it created a closure. And so that's exactly what happened. And yeah, that's how we got access to per group and also this argument of the function, so this weight here, right? So as I mentioned in the last lecture, the closure, of course, also includes the arguments, and that's because there are really just local variables in the function. And to finish, let's now also prove that the closure does, in fact, have priority over the scope chain. So here in the global scope, I'm also going to create a variable called per group equals, and then just some value here. And so if the scope chain had priority over the closure, then this callback function here would indeed use this variable here, this global variable, because we can imagine this function here basically being executed in the global scope. Okay, so if it wasn't for the closure, it would use this. So let me actually demonstrate that to you. So if I remove this variable, then it will be able to use the per group, and that is here outside. So indeed, now we get 1000. But then, as we put it back here, then the callback function will close over this variable. So it will close over the entire variable environment, in fact. And so therefore, it will then use this here first, right? And it did. So, in fact, the closure even has priority over the scope chain. Okay, and with this, we finished these 2 lectures about closures. And I hope that after this one, you are now a little bit better able to identify closures as they happen in your code, or even here in my code throughout the course, because we will see some closures happening some more times in the future. Now all there's left to do is the coding challenge in the next video, where you will be thinking about closures one more time. To make sure 100% that you understand closures now, let's work on this coding challenge number 2. And actually, this one is more of a thinking challenge than a coding challenge. So what I want you to do is to take this iffy here, and at the end of the function, simply attach an event listener that changes the color of the selected h1 element, so this header here, to blue. All right? And that should happen each time that the body element is clicked. So whenever we click here. And what's important here is that you do not select the h1 element again. So just use this header that you have here. All right? So that's all the code you have to write, which is really simple. But the real challenge here is that I want you to explain to yourself or even to someone around you why this works. So as you click the body, the text will change to blue, and so it's going to work, but you have to understand and you have to explain why it worked. And so this is a good exercise, because being able to explain something to someone else means that you have understood it yourself. So I really hope that you do this one, even though it doesn't involve a lot of coding, but it's still really important to do this. So take all the time that you need and think about when exactly the callback function is executed, and of course what that means for the variables that are involved in this example. So again, take the time that you need, and I see you here in a minute with my own explanation, basically. So the code that you had to write was simply this. So selecting the body element and then add event listener on click and then this callback function. And then I'm simply changing the style here to blue. And keep in mind that we did not select the h1 here again. I simply used the header variable that we had already selected before. So let's give it a save. And I will click now the body. And indeed, it became blue and that worked just fine. So why did this work? Or in other words, how does this callback function here get access to the header variable? And one more time, the explanation is the closure. So I hoped that you really explained basically how the closure works to yourself or to someone else. And so in this particular example, the closure is necessary or it's useful because by the time this callback here is executed, this IFI, so this immediately invoked function expression is now long gone. So it has already been executed, and with it, this variable here is basically gone as well, right? So all of that is gone, but still this function here is attached to the body element. And so it's waiting for some event to happen there. And when the event happens, well, then this function here is of course executed. And again, even though the environment in which this function here was created is already gone, it is still able to access the variables that were created in that variable by the time the function was born, so to say. So this is the birthplace of our event handler function here, and therefore the function remembers all the variables present at the time of its birth. We can also say that the header is in the backpack of this function. So that explanation works as well. And you can go even further and deep into theory and basically try to explain how all of this works behind the scenes. But that I already explained you in the more theory lecture, and so I'm not going to go into that again. All right. So hopefully you managed to explain this to yourself, maybe to your dog, whatever. But what's important is that you now understand how the closure works and how and when it appears. So this was yet another great example of a closure appearing. Anyway, with this, we finished this pretty important section on functions. And so in the next one, we will finally build another visual project with a graphical user interface, which is really exciting. So that section is all about arrays, and we're going to build together an awesome application there. So I hope to see you there as soon as possible.